about in genetics has been Mendelian genetics, like Gregor Mendel style. Mendelian genetics means that for every trait, there's a dominant there's one dominant allele and there's one recessive allele. And that's it for each trait you look at. So for example, in pea plants, we said height. The trait was height. The dominant allele was tall. The recessive allele was short. Those are your only two options. That's the only way it's ever going to happen. End of story. There are a lot of genes that work that way. That's true. It's a lot. But not all genes work that way. Some genes have more than two potential alleles. So there are more than two possible things you could see. You could think of some really obvious examples of some of those traits, like hair color. There are more than two choices for hair color. Eye color, more than two choices for eye color. Anytime that we have that happens like that, we consider a trait that has multiple alleles to be non-Mendelian. Just meaning it's not simply dominant versus recessive, or it's not simply, allele 1 or allele 2. There could be allele 3, there could be allele 4, there could be allele 5. So in that instance, the first one we'll talk about is called multiple alleles. So far when we've examined traits, like I've already said, we've seen only two potential alleles. One dominant, one recessive. God bless you, if you have more than two possibilities, that's what we're looking at here. A classic example of multiple alleles that we talk about, and this is the one that I absolutely could not allow you to leave biology without knowing, is human blood typing. Now, how many of you know your blood type? How many of you know what the human blood types are? Okay, 1, 2, 3. How many of you know what it means when we say blood types? Don't we all have human blood? So what the heck does this whole blood type thing mean? Yep. That's one blood type. So the potential blood types that we have in humans: A, B, AB, or O. And you are going to be one of those four. There are no other possibilities other than those four. And your blood, your red blood cells are shaped like little Smarties, right? Or little donuts with an indent on them. Everybody's blood cells are shaped like that. But on the surface of your blood, there are proteins embedded. And the shape of your protein that's embedded on the surface is the type of blood that you have. Now, it doesn't surprise you that we're talking about genes, and a gene is going to code for a protein of a particular shape. So based on what we have here, there are two potential shapes. I know you're looking at it, you're like, wait a minute, there's 4 blood types. How are there only 2 potential shapes? Well, for someone with type A blood, here's their bell. And on the surface of their blood cell, they have these little proteins that stick out that are one shape. And if you get the A allele, the surface of your blood has that on it. If you have B blood, so you got the allele that codes for B, the protein on the surface of your blood is a different shape, so zigzags instead of curlicues. If you got type AB blood, you have a combination of the A curlicue and the B zigzag. And if you got type O blood, there are no shaped proteins sticking out of the surface of your blood cell. There are none at all. So I usually have students at this point ask, well, what does that mean to be the universal donor or universal recipient? But if you guys don't know what your blood types are, you've probably never heard that before, right? You know why the Red Cross makes the big fuss they do about getting blood? So they need blood for operations, for surgery, for people who are injured. They have to give them blood if that person can't produce enough of their own blood. But they have to be very particular, and they have to make sure that they only give the individual blood that has the same surface proteins that the individual makes. Remember, your body is a fine-tuned machine. Its job is to recognize foreign invaders, attack them, and kill them so it doesn't get sick. One of the ways that your body does that is by recognizing things on the surfaces of cells, seeing it as a foreign invader, and then attacking it if the thing doesn't belong. If the protein says, hey, I don't belong here, then your body turns on it and kills it. So if somebody who has type A blood needs blood at the hospital, the doctors can only give them other type A blood because their body will recognize the curlicue proteins on the surface. Now those people with type A blood are fortunate. They can also receive type O blood. There's nothing on the surface of O, right? If your body's job is to recognize what's on the surface and there's nothing to be recognized, then it won't get attacked. It's accepted as a regular body cell, and it may proceed about its job as blood. A type B individual has to receive type B blood, or they can get type O. That's fine too. Type AB people are lucky. Type AB people can receive type A blood because their blood has that zigzag or that curlicue. Type B blood because their blood has that zigzag, or type O blood. So if you are type AB, winner, winner, chicken dinner, if you ever need blood, anybody's blood will do. You're like, hey, absolutely, sign me up, anybody.
What about, like, I've heard, like, A positive or...
So when we talk about blood types, you usually hear A positive, A negative. The positive or negative refers to a different part of the blood called the rhesus factor. And it has to do with another protein found on the surface of your blood. So in order to figure out an individual having type A blood or AB or B and their rhesus factor, that requires a 16 square Punnett square because it's a different trait. But that's what it refers to. If you are positive, you have the protein, and if you're negative, you don't.
What about, like, a mother that's, like, has a different blood type than her baby?
That is not horribly uncommon. And we'll see why when we do Punnett squares that it's not uncommon. It can become a serious problem later in pregnancy and during birth that having a different blood type than your child is a problem. It's not so much a problem as it used to be, but it leads to more sickness during pregnancy, usually not good. More so than the type of blood they worry about the rhesus factor, the positive negative thing, because that can make you super sick. But miracles of modern medicine, we can overcome that now. Isn't that fortunate for us? We can overcome so much that we could never overcome before. People would just die. It's an upper for Monday morning. Come on, you knew it was coming. I forgot my coffee on my counter at home. So, type O blood, poor friends with type O. Guess what the only blood type they can receive is? O. They can't get A, they can't get B, they can't get AB. They only get O. But everybody else can receive type O blood. O's are givers. If you ever go and donate blood at the Red Cross, they blood type you. It's one of the first things they do, and then they give you this little donor card, and it has your name on it, and the number of times you've donated, and your blood type, and your donor number, and they'll call you every 6 months to have you come in and give blood. They are much more persistent when you are type O. Type O is referred to as the universal donor. They can give to anybody. So they definitely want lots of type O blood. So our universal donor is type O. Our universal recipient, I can take blood from anybody. Those are our lucky AB friends. They can take anybody's blood, life is good. So this is the good point in time for you, my friends, to figure out what kind of blood you have. Your parents likely know they blood type you at birth. Why do they blood type you at birth? Well, they are going to try and figure out if you're going to try and kill your mother. It's important. They need to know. If you have a different blood type than your mom, it makes your mom really sick because the fetal cells are floating through your mom's bloodstream. And if you're different than mom's body is going to turn on those blood cells floating through her bloodstream.
Mom's body when it turned out the baby.
So it is life-threatening for both parties involved.
Oh, that's nice.
Yep, biology. Ain't that a thing?
Who would usually survive in the
Both survive now. It hasn't been an issue that would kill someone in the United States since probably my mom was born. So 1952. Well, okay, that's when my mom was born, but it was probably shortly before that. That wasn't my mom's birth that figured it out. It's just ballparking it. I know because my mom and my grandma was really sick with my mom, and that's why. Because my mom and my grandma are different. My mom is positive and my grandma was negative, and there you have it. Fabulously for my sisters and I, we are all A positive. My mom is A positive, so life was good. It's worth thinking about, worth considering, knowing what you are. It's worth knowing what you are. They'll blood type you if you ever need a blood transfusion at the hospital. They're not going to trust you. They won't. You roll in on a gurney, you've been in some kind of accident, you're bleeding out, and you're like, I'm A positive. They're going to be like, oh, okay. They're going to double check. They like you, they want to save you, but they're not going to trust you. They check before they give you blood. If you give somebody the wrong blood, it will kill them. Yeah. So the exact thing that was intended to save you will be the death of you if they do it wrong, which is why they don't trust you. That's why they're like, thank you for that information. And they double check. There are 3 alleles that you can inherit for blood type. You can get an allele for type A blood. You can get an allele for type B blood. If you have type AB blood, that's not a 3rd allele. If you have type AB blood, we know your genotype for an absolute fact. You have 1 type A allele, and you have 1 type B allele. So what this demonstrates to us is not only are there multiple alleles for blood types, one is not dominant to another. If you have an A allele and a B allele, you don't express only A or express only B. You express both of them. We see both of them. Poor little O. O is recessive. So if you get an allele for O, it's lowercase I. Notice the alleles for A and B, they're uppercase because they are what we call co-dominant. They are both dominant. O is hidden, it's masked. If you inherit anything from them, well, so sad. So I will tell you how this works. My mom. my mom and dad, they made a family on, well, they founded a family on October 4th, 1975. And in 1979, they had my sister Sarah. Her blood type is A positive.
Wait, you know your sister?
Yeah.
Oh, they're all.
Well, we're all the same, and my oldest sister, Sarah, has had 2 kidney transplants and has needed some blood transfusions and that. So, you know, when your sister needs blood, you go to the hospital, you bleed into a bag for her. You're like, yeah, it's cool, you can borrow that. See, you shake your head no, like you wouldn't do it. Yes, you would. You would go to the hospital and offer an internal organ. How do I know? Because I've done it before.
They're pretty mean to me, so I don't know.
You know what? This sister that's up there, she has tormented me since the day I was born. She still torments me. And I still went to the hospital and was like, oh, you need an internal organ? Try mine.
My sister wouldn't give it to. Like my 7-year-old said, no, she wouldn't. She's a little demon.
Trust me.
No.
How do I know? Because this sister, who was born in 1981, is the one that we would classify as that little demon, and she is the one who gave Sarah an internal organ. So even though you think they wouldn't, they will.
I don't think my sister would. She's too mean.
And my mother gave the first internal organ. My mother, Gail, is A positive. And then you have me, who was born 2 years later, who is A positive. Bob. Oh, Bob. You would think the Red Cross would love Bob. He's type O. He's O positive. Oh, but dear Bob is the slowest bleeder ever. No matter what size needle they stick in him, it takes like an hour and a half to get enough blood. Me, I go and it takes like 10 minutes. I'm like, give me the biggest needle you got. Let's get this over with. So they actually asked him one day to like, please just stop trying. Stop trying. But now, knowing what we know, we can figure out the genotypes. We know the phenotypes for my sisters and myself, right? We know exactly what they are. But we can figure out the genotypes for our blood. My sister Sarah must have gotten an A allele from my mom because the only thing my dad has to give is an O allele. So that would be her genotype for blood type. She'd be IAI. Sue, same story. And me, well, I'm no different. So 3 of their 4 children are IAI. If we were trying to make a Punnett square for this, we could put my dad across the top because we know my dad being type O, his genotype must be little I because O is recessive. So you have to be a homozygote. My mom, we only know this much. We know she is IA. Oops. Need the eraser. Now we have to write question mark for my mom's other allele. That's not a question mark, that's an IA. I apparently don't know what a question mark is. Though there are 3 of us, and the 3 of us all have the same blood type, and we know what our genotypes are, we cannot guarantee for sure without looking at my grandparents what my mother's second allele is. We could try and say, well, it's a high probability that it's another IA because she had 3 children who are all type A and no children who are type O. That would be the other option, right? She could be IA little I, and then one of her kids could have been type O. Mm-hmm.
So that means she had like 2 that she could possibly.
Mm-hmm. So there are two potential genotypes my mom could be. She could be IA little I or IAIA. Both of those will produce an individual with type A blood. We don't know though. We can't say. And it's tempting. How many of you are so tempted to say, but 100% of her children are IA little I? And if that's true and they're not little I, then she's very likely homozygous IA. We want to do that, but 3 is not a statistically significant number. 3 is not good enough. I'll give you another example of why we can't do that. That has an awful lot to do with Bob and my happy little family. So, Gail, my mom's a girl. I know, you're shocked. And my dad, wait for it, wait, you're gonna be stunned. My dad's a boy. Woo! Craziness. It's genetic stuff, it's rough. I've written up here the 2 potential sex chromosomes. Every female has 2 X's, right? XX. And every male is XY. So, in a potential cross of my parents to determine whether they're going to have boys or girls, it predicts that half of their children should be boys and half of their children should be girls, just from the Punnett square, right? It's a probability thing. But in real life, what happened? All girls. If we were to try and reverse engineer like we did for blood types, and we looked at the genotypes of the offspring, wouldn't it be so tempting to say that Bob must only have X's? Like, well, clearly, all 3 children, they only have X's. Bob must only have X's. But then what would happen to Bob? Bob would be a woman, and that would have been awkward through childhood, right? Would have had a lot of explaining to do, because he'd be my biological father. Just so we're aware, the biology there, it doesn't work, does it? Poor Bob. Poor Bob. We could make it even worse. We could take a look at Sue and Sarah's families. Sarah, on October 16th, 2005, married Brian. I was in their wedding, I better. Right? I mean, you guys know your parents' anniversary, right?
Yeah.
It's like August.
It's November.
All right, so when you go home this evening, your job is to be like, I have a biology assignment. What's my blood type? And when did you and, when was our family founded?
Honestly, my mom doesn't even know her wedding anniversary, so.
That's why you have it inscribed in your wedding band. Like, it's real simple then, right? You just slide it off and look when you get confused. Not so much for me. I'm very good at remembering these dates, especially. But I'm good at remembering the date because we purposely got married on my grandpa's birthday. So I'm not going to forget that date. But I had it put in my husband's just in case. Mm-hmm. There are, some of us were thinkers. We plan ahead. So Sarah and Brian were married. And Sarah, per our previous discussion, girl, they have 2 little ones. Gianluca and Paolo. Gianluca is a little boy, and Paolo He is a little boy. Looking at that, here's Sarah. It sure would be tempting to say that Brian is question mark why, right? You're like, well, I don't know. They've only had boys. Maybe Brian only has Ys to give. But we know that that's actually a physical impossibility. So you have to be really careful when reading a Punnett square. Really, really, really careful when reading them. To understand that we can make predictions based on probabilities, but they don't have certainties. Here, the certainty is we know for a fact that Brian is XY. And we know for a fact that Sarah is XX. That's how you become male and how you become female. So we know that those are the only two choices. And the only way it could work out is 50% boy, 50% girl for probabilities, which then takes us to October 8th of 2005. Yes, I know that one too. When Sue married Rob. And they had their first little one. And then they had a second little one. And then their third. Yes, which is going to be quite confusing come September because number 4 is arriving and I'm betting it's not going to be an A name. I got money on it because she had her ultrasound 4 weeks ago and it's a boy.
Alex.
Her logic for why she went with Amelia, Alice, and Abigail, this is stunning logic. Only my sister could pull this one out. People gave her stuff embroidered with the letter A when she had Amelia. And she didn't want to have to get new stuff for the second kid because it was only like a year and a half later. So she's like, I mean, really? It's another girl. I can just reuse all that clothing with the letter A on it. I'm just gonna have another A kid. And then little Abby Cadabby was born, and well.
There's a bunch of A names in the sky.
Well, the thing is she can't reuse the embroidered stuff because it's all like pink and girly, right? So since it's a boy, she can pretty much choose anything she wants because she's gonna have to get all new stuff.
Well, pink is universal.
You have met my brother-in-law. Yeah. That wouldn't go well. So.
Basically, Alice and Abigail are based off Amelia.
Yep.
So,
I told you. Only my sister.
Does Alice and Abigail know her?
Alice and Abby Cadabby just turned 2 yesterday. So right now what she knows is that she got to pick out her outfit for her birthday and she put on a bathing suit. So she spent the day in the house yesterday running around in a bathing suit. She went to church in her bathing suit because it was her birthday and she got to wear what she wanted.
At least she knew in her birthday suit.
That is actually true. I did tell her that. I was like, you're only one step away from a birthday suit. And she just kind of looked at me like. Well, poor Abby Cadabby. She still doesn't know. Alice, on the other hand, oh, little Alice. She would understand, but she's pretty much convinced that she's the center of the universe, so I don't blame her. Yeah, she's her preschool teacher. They did their preschool graduation the other day. And you know how for graduation here, the seniors give you like mock elections of things you're most likely to be? Alice got born for stage. And fashionista. Those were her 2 awards from her teacher. That's my little Alice. She's also the one who told my sister because she has brown hair, she's only allowed to go to the grocery store. Only girls with golden hair like Auntie Liz get to go to the ball. Yeah, we're really into princesses. So, she's like, sorry, Mom. You can only go to the grocery store. I was like, but you can't laugh because you can't encourage the kid, right? Because that's not right. So I was like, that was rough. But I get to go to the ball, so it's all good. I don't care. Based on this, though, oh my goodness, what would Rob have been if we had reverse engineered and made some inappropriate assumptions? He'd have been XX. Thank goodness for Mystery Child coming in September. That at least lets us know, praise be to God, Rob does have a Y.
I got money on that.
I'm going with B. I tried like some really interesting A names for boys. Athanasius, Adelbert, and my sister was like, you can stop talking. I was like, these are great names. They're all saints. Something your other kids don't have going for them.
Amelia. No?
Nope. Her middle name is Casey, though, so she at least has Father Solanus Casey. No Amelia, no Alice, no Abigail. Ah, Sue. At least Gianluca and Paolo, they got saints going for them.
So essentially,
Is Scantamburlo.
Wait, what?
They're her married name, you know. We all were Giza until we all got hitched. And then, you know, one turned into Long, one turned into Scantamburlo, I turned into Bloomfield.
long just spelled L-O-N-G.
Yep. Amelia, Alice, and Abigail Long. Gianluca Scantamburlo, it just fits.
Just rolls off the
I
tongue.
would hate
Yep.
to spell that name.
Yeah, he's in kindergarten. Ask him how it goes. You know what he tells everybody his name is? G. That's his nickname at home, G. So, the two traits that we have to understand then are multiple alleles, how we can have multiple things at the same trait, like our blood types, where we have IA, we have IB, and we have little I, and the sex chromosomes, X and Y. Remember on X and Y, those are entire chromosomes. Those are not just alleles like everything else. An allele is just one gene. A chromosome is composed of tons of genes, right? But it's important to look at it so we understand. I don't want you to go out into the world and say such ignorant things as people do about, oh, you've already had 3 little girls. Bet you're going to have another little girl. Think, really? Based on what scientific evidence
My
would
parents
you
had 3 boys and me.
see?
What did I say about my mom and my dad? 'Cause
Yeah.
I'm one of 3 girls. And honestly, I'm not having.
My husband is one of 6 children, and there's only 1 girl amongst the lot.
Oh, I feel so bad for
She's pretty feisty and independent. And she was older, so it was my husband and then her, and then all the other boys were born, so. Oh, wait, no. 1, 2, 3, 4. Yeah. Yeah. The twins confuse me, because the twins are identical twins, so they're obviously both boys. Ended that bunch with twins, which I think is hilarious, because like, right, you've got all these kids already, and you're like, oh, we should have another kid, and then you get twins.
Going for 4, gets 5.
Exactly. Precisely. But at that point, I mean, my husband's mom was like, I mean, really, what's 1 more? What's the difference between 5 and 6, really? We use this multiple alleles to predict paternity or maternity if need be. In cases of people trying to figure out if they are members of a particular family or aren't, it's very easy to determine based on blood types. And sometimes it's not so easy to determine based on blood types if you have that sneaky little O allele. So if you're type A, your potential genotypes are if you're type B, your potential genotypes are And if you're type O, that's your potential genotype. And if you're type AB, you are IAIB. Based on that knowledge, is it possible for a type O man and a type AB woman to have a type AB child?
Yeah. Yes.
Is it possible for a type O individual and a type A individual to have a type B child? Nope, no B alleles to give there. Is it possible for a type A person and a type O person to have a type O child? Yes, but in only what circumstance? When they're heterozygote for type A, right? When you're IA little I. Type O, well, we always know what they are. So type O and type AB are the easy ones. Their genotypes are guaranteed. Type A and type B can be either heterozygotes or homozygotes. That's what makes that non-Mendelian. It's not quite as simple and pretty as that whole dominant recessive thing, right? Is it possible for a type O man and a type AB woman to have a type AB child? No.
No?
Their only choices of children then are going to be either type B or type A.